Students, it is a second lecture of this week of sampling techniques. Here I have started chapter number 9a, single stage cluster sampling, where the cluster size are unequal. In most of the applications of clustering techniques, the clusters are consist on countries, cities, blocks, households, and so on. But often the size of the units included in each clusters are not similar. The previous lectures was consist on the clusters having the same size, but here the size of the clusters is not same. For the estimation of population total of Yij, I mean the ith observations and j mean the number of clusters. Two methods are already, we are familiar with two methods. Making estimation of population total, simple random samplings of n clusters. For unbiased estimate, simple random samplings of n clusters by using a ratio to estimate. So now I have explained simple random samplings of n clusters, unbiased estimate. Let mi be the number of elements in ith clusters or units. Because we have different numbers of units in each cluster, so the size of m will be changed for each clusters. Y is equal to sum of j varies from 1 to mi yi j, where j is equal to number of clusters. Now multiply on both sides mi into j varies from 1 to mi yij mi. Now it is the mean at jth clusters yi bar, which is the ith clusters total number of units in ith cluster. This is the total number of units in ith cluster. Estimates of total number of clusters in ith units in ith cluster. For simple random samplings of size n, units are unbiased estimate y hat is equal to capital N divided by small n, sum of I varies from 1 to n yi. This is the way where we have to find simple total in simple random sampling. And the variance of y hat is equal to n square 1 minus f over n, sum of I varies from 1 to capital N yi minus y bar whole square divided by capital N minus 1, where y bar is equal to yi divided by n. Y mean sum of y observation in population, the sum of the observations in population. Yi means sum of I varies from 1 to capital N yi. Is the estimates y hat is often found to be poor precision because yi bar mean per element very little from cluster to cluster. It means the units, the number of units in each cluster will be vary from cluster to cluster, and the cluster of size mi greatly large, then y is equal to mi yi bar, mi is equal to very large, yi is equal to very small. Therefore y is equal to sum of yij, yi bar is equal to sum yi divided by n. Sum of yi means sum of yi, so sum of elements in ith clusters. Variance of y bar is equal to capital N square into 1 minus f divided by n, sum of I varies from 1 to capital N mi yi bar minus m into y double bar whole square divided by capital N minus 1. This will be the cluster sampling unbiased estimates. For samples Variance of y hat is equal to capital N square 1 minus f bar n sum of I varies from 1 to capital N y minus y bar whole square divided by capital N. Here y is equal to mi yi bar, that is y bar is equal to m into capital Y double bar. Simple random sampling of n cluster ratio to estimates. Let the total number of elements in the population is equal to m naught. Total number of elements in the population is equal to m naught. I varies from 1 to n mi. This is the sum of the elements in each clusters. If all mi's, unknown ratio estimates can be used by taking mi in place of xi. Therefore, y hat r is equal to r hat x, and r hat will be replaced by the ratio I varies from 1 to small n yi divided by I varies from 1 to n xi into capital X. Y hat r is equal to x is replaced by capital X is replaced by m naught, and sum of I varies from 1 to n xi is replaced by mi. I varies from 1 to n. Therefore, sum of I varies from 1 to n yi divided by mi is the sample mean per elements. Y hat is equal to m naught, y hat r is equal to m naught. In ratio estimate, variance of y hat is equal to n square 1 minus f bar n sum of I varies from 1 to capital N yi minus rxi whole square divided by capital N minus 1. Xi is replaced by mi. Therefore, variance of y hat r is equal to n square 1 minus f bar n sum of I varies from 1 to n mi yi bar minus mi y double bar whole square divided by capital N minus 1. Y is equal to sum of j varies from 1 to n yi j mi is equal to yi bar. Taking common mi square, we have obtained this expression. Variance of y hat r is found to be much smaller than variance of y hat because y hat r depends on variability among the mean per elements per cluster. Note that the y hat r represent the total of m naught of all mi's, where y hat is equal to capital N over small n. I varies from 1 to n yi. Does not require that the knowledge of all mi's when we are estimating the population mean per elements. In this case, the corresponding estimates is equal to y hat. Y double bar hat is equal to y hat divided by m naught, and y hat will be replaced by capital N in divided by n into I varies from 1 to n yi divided by m naught. Y hat bar is equal to y hat r is equal to y hat r divided by m naught. Y hat r is equal to m naught I varies from 1 to n yi divided by m naught I varies from 1 to n mi. M naught and m naught will be cancelled out from both denominator and nominators. After making some replacement, we had y double bar head is equal to sum of I varies from 1 to n, I varies from 1 to n mi. Hence, y double bar r requires knowledge of all mi's which are selected in the sample.